All right, this is 8.2 heat. Heat, the definition, is a type of energy, and specifically it's energy that's being in motion, energy that's being transferred. And so anytime you have a transfer of energy, that is heat. A good example we can see here, if we have two metal blocks, one which is 30 degrees Celsius and another which is 45 degrees Celsius, if we were to put these two together and have them touch, what's going to happen is we're going to have a flow of heat from the block that has a higher temperature, let's call this block B, to the block that has a lower temperature, block A. And so we're going to have a transfer of energy from one to another, and this transfer of energy, this little squiggle line, which I drew horribly, I'm sorry, is heat. This is what we call heat. Students have a tough time with heat, and sometimes energy in general, because you cannot see it, right? You cannot see heat. It is invisible, and it's not something that's, how do I put it? It's not something tangible. Again, it's something that happens in motion. It's the energy of motion. It's energy that's being transferred. And so students oftentimes have a hard time thinking about this. The example that I use with you guys to help you guys understand this is, let's say you have a friend, and this is your friend, and I am a horrible artist, I'm sorry. I'm a little bit better at chemistry than I am at drawing. And so this is your friend. Let me move my eyebrows too. And what you can see is your friend has quite a long neck. And of course, you being the troublemaker that you are, you think it'd be hilarious if you take your hand and put it on his neck, right? And so I guess just to make sure you know, this is you. You're a separate person. Right, and so what you are thinking, this is the extent of my drawing. What you're thinking is, yeah, it'll be hilarious if I put my hand on his neck. And when you do that, what your friend will say is you are a jerk because your hand feels cold, right? And what's happening, why your hand feels cold in that moment, or why your hand feels cold in that moment to him, is that basically your hand has less energy than his neck. And so what's happening is, the neck is a nice 98 degrees Celsius, and the hand is going to be lower because it's, that's actually where most of the heat from your body goes out of. I don't know exactly what it is because I don't know physiology, but let's say it's 90 degrees, right? And so in this moment, right, when you put your hand on his neck, if his neck is 98, your hand is 90 degrees, what's going to happen is there's going to be you're basically stealing energy from him. You're taking his energy. And so, despite the fact that your friend says, hey, you're making me feel cold, you're actually not making him feel cold, interestingly enough. What you're doing is you're just taking his heat. And so, in some senses, there's no such thing as cold. You cannot make him cold. There is no cold. What he's actually doing is he's making your hand warm. The jerk, right? And so, next time you do that to your friend, boys, please don't do that. It's actually really annoying, right? But if you do that, that's what's happening, right? What you're doing is that is heat. That is energy being transferred. And so hopefully that gives you guys another a way of thinking about it. That's one thing that's difficult in this lesson, but another thing that's difficult is this idea of the math of it. And so the math of it, we can calculate heat using this equation, Q is equal to mc delta T. Q, heat, is we oftentimes call it Q. And so here, this is the heat equation. We're saying heat is equal to mc and delta T. Now, what are these other things? Well, m is equal to the mass of the object, whatever it is. C is equal to the specific heat capacity of the object. And then, lastly, delta T is referring to the change in temperature of the object. And so what's happening here is if you have some sort of object which is transferring heat, either it's gaining or losing heat, we can actually calculate the amount of heat that it gains as a result of seeing how much its temperature changes and also factoring in its specific heat as well as the mass of that object. I call specific heat the tolerance of a object to getting heat to it. And so basically, if something has a very high heat capacity, that means that it can take on a lot of heat without its temperature changing. you know, honestly, there are a few lessons where I think my slides are better than me, you know, what I'm teaching you guys directly right now. But actually, I do think my slides are much better. And so, because I have like a lot of pictures and a lot of examples, which help clarify a lot of these things. But yeah, you know, this is the equation. This is high heat. This is what heat capacity means. I had an example again on the slides with concrete versus metal bench, and the metal bench, in essence, you don't want to be on it because it has a very low heat capacity. It gets hot very quickly. Versus concrete, it's much better at taking on heat and its temperature not changing. Water, if you take AP Bio or the water class that we offer here, you'll also learn that water has a very high heat capacity. And it in essence acts as a heat sink of sorts, which allows for us to have very temperate temperatures if you live near a body of water. And so yeah, this is the basics of heat. Q is equal to MC delta T is the big thing that you need to know and to understand. I'll make a separate video on that for you guys soon. Or I'll just go through a packet of problems and go through those. But, you know, that's the basics of heat. That's what you need to know. And we'll make another video soon with some calculations.